Okay, fifth grade. So here's your second video. I went ahead and decided to do 2 different days just because rational numbers can be a little difficult. And so we're going to spend a couple of days on that, especially since we're not face to face. This is usually one of those harder lessons. Um, so we did rational numbers, and you did an activity where you had to put numbers based on their characteristics and put them in the Venn diagram. And then you had to answer some true and false questions. So we're going to move on and we're going to continue this lesson by looking at terminating decimals and repeating decimals. So terminating and repeating decimals are rational numbers. As I can write this number, 25 hundredths, I can write this as a fraction. So that is the same as 1/4. Okay. And we know how to convert decimals to fractions and fractions to decimals. So we're going to look at this fraction here, and we're going to convert this to a decimal. And then based on that, we're going to see if it's a repeating decimal or a terminating decimal. So terminating decimals are decimals a decimal that stops and it terminates. So for example, we have 25 hundredths. There are no more digits after 5. Like if I just had 0, I could write 0, 0, 0 all the way. And so it stops, it terminates. The next one we have is a repeating decimal. It's a decimal that repeats indefinitely, and we represent it with bar notation. Bar notation is a bar that's placed over the digits that continue to repeat. So we're going to look at 5/12 here, and we're going to write this as a decimal. We're going to express 5/12 as a decimal. So remember we talked whenever we're dividing fractions, or we're expressing them as decimals, we're going to use that TIBO acronym, which means top in, bottom out. So whenever I divide, I have 5 and then I have 12. Okay. So I know that 5/12 is going to be a decimal. It's going to be a number that is less than 1. So I'm going to ask myself, how many groups of 12 are in 5? There are 0. And I'm going to continue to find out. Remember, my goal is to have a remainder of 0. So I'm going to add a decimal and a 0. So now I can look at it as how many groups of 12 are in 50. So when I look at that, 12 times 4 equals 48. I will subtract, and I'm left with 2. Remember, our goal is to have remainder of 0. So I'm going to continue. I'm going to add another 0 here. So now I'm going to ask myself, how many groups of 12 are in 20? There's only 1. 12 times 1 is 12. I subtract 12 from 20 and I get 8. Same thing, 0. Bring my 0 down. How many groups of 12 are in 80? Well, I know 12. I'm going to extend this line. 12 times 6 is 72. I subtract 80 from 72. What do I get? I get 8. Okay, remember I want my goal to be 0. I'm going to add another 0 here. How many in there, right there? So how many groups of 12 are in 80? I'm going to put this 6 here. 12 times 6 is 72. I subtract, I get 8. So here I'm starting to notice a pattern. Okay, so right here, if I added another 0, I'm going to get 80, and I'm going to repeat this same pattern here. So here, this tells me that the remainder will never be 0. It's going to continue the same pattern. Will not equal 0. It's going to continue the same pattern, okay? So 5/12 as a decimal, I'm going to express that as 0.41. And what digit keeps repeating over and over again? I'm sorry, let me move that down. If I continued here, the remainder will never be 0. It will not equal 0. So I'm going to continue with that same pattern over and over and over again. So what digit continues to repeat? 6. So I'm going to put that bar notation over that 6, and what that tells me is every time I continue to do and continue to divide, the number that's going to always repeat is 6. So my remainder will never be 0. Okay, so that's an example of a repeating decimal that uses bar notation. Okay, so I'll keep that there so you can pause it and rewrite that. So now we're going to look at another one. Let's look at 1/6. So we're going to do 1/6. We're going to express this fraction as a decimal. Okay, so remember I'm going to use that Tybo top in, bottom out whenever I'm dividing. So I have 6 and then I have 1. Okay, so now what I'm going to do is how many groups of 6 are in 1? There are 0. Add that decimal. Okay, so I'm going to ask how many groups of 6 are in 10? There's only 1. 6 times 1 is 6. I subtract. I'm left with 4. I'm going to add a 0 here. So now I have 40. So how many groups of 6 are in 40? Well, I know 6 times 6 is 36. I'm going to subtract 36 from 40. I'm left with 4. Add a 0 here. I'm going to ask myself how many groups of 6 are in 40. 6 times 6 is 36. And you're going to start noticing a pattern. Well, what is happening every single time? If I continue to add this 0, I'm going to have 40 and I'm going to repeat this pattern. So this right here will never equal 0. Okay, my remainder is not going to be 0. So what digit kept repeating over and over again? This 6. So 1/6 expressed as a decimal is the same as 0.16, and the 6 is repeating. So that bar notation goes over that 6. Okay, so that's what we're going to do. We're going to continue expressing decimals as fractions, fractions and decimals. And based on what we get here, where would 1/6 be located on our Venn diagram? Well, this would be a rational number because rational number is any number that can be written as a fraction. So decimals can be written as fractions and fractions can be written as decimals. So that's why this is a rational number. So today we're just going to practice converting and determining whether or not these are rational numbers.